Hello, hello, hello everybody, and welcome back. We're looking at question number 2 now, which says, if possible, determine the value and, they've given us a limit. Now, we haven't talked a whole lot about limits in the last little while, other than L'Hopital's rule, so I might think, this might be a L'Hopital's rule style limit. Okay, well, we do a little bit of investigation. We've got 5 to the 1/5. Or not 5 to the 1/5, x to the 1/5 x. Sometimes I read things, but my mouth doesn't agree with me. Okay. So what happens? Just really basically plug in. The x would go to infinity. The 1 over 5x would go to 1 over 5 times infinity. And that's roughly infinity to the 0. And this is a L'Hopital's rule situation. So we'll say L'Hopital's rule will eventually apply. We don't just derive the two functions that we see, the x and the 1 over 5x, but what we can do is we can rearrange this so that L'Hopital's rule will apply. So we'll get down to a 0 over 0 or an infinity over infinity style situation. Okay. So what am I going to do? Well, it's an exponential one, and we covered a few of these in class. They're all done the same way. We'll change the x into an e to the ln x. And now we can simplify this a little bit. E, and the 1 over 5x will just come in down here. But e is continuous. Well, e isn't continuous. When I say e is continuous, I mean e to the x is a continuous function. E on its own is a constant. Which I guess technically is a continuous function, but I mean e to the x is continuous. So what happens? The limit can shift inside. This is something we've known since we talked about continuity with 2.5, so it's quite some time ago. Okay, so to answer the original question, we have just rewritten it, same expression, or same ultimate meaning, different expression. Again, different expression, and then we brought the limit inside. So now, to answer our original question, we just need to simplify this other limit. And we plug in, and the ln of x goes to infinity as x goes to infinity. We might need to remember what ln of x looks like. And 5x. As x goes to infinity, 5x is going to go to infinity. Okay, so this is one of the two cases where L'Hopital's rule will apply. Okay, ln x has a derivative of 1 over x, 5x has a derivative of 5, so this is going to be the limit of 1 over 5x. And as x tends to infinity, we've seen this before, this goes down to 0. Does that mean the final answer is 0? No, no, no. This 0 gets plugged back in here. So we get e to the 0, and our final answer is actually 1. I can't remember, but, yep. See, 0 is here for the people who are doing this too quickly. In fact, our answer is going to be B1. Okay? Onward to question number 3.